Dear students, I hope that you are all well and excited for today's lesson. So today we are going to discuss Chapter 2 of Science of Class 9, Is Matter Around Us Pure? Before starting with the chapter, let us revise few things which we already know. Students, now tell me, when you enter the kitchen of your house, what all objects do you see? You would say that utensils, eatables like milk, ghee, water. Now you tell me, are these substances pure? You will say that they are pure substances. As a layman, we can say that these substances are pure, but scientifically speaking, these substances are mixtures. A pure substance is the one which is composed of only one type of particles, whereas all these articles, they are made up of more than one component. The pure substances are the ones which do not contain any adulterants. But in terms of science, the pure substance is the one which is made up of only one kind of component. So, substances are of two types, pure substance and mixtures. Let us know about them in detail. Students, we may categorize the substances present around us in two categories, pure substances and mixtures. Pure substances are those which are made up of only one type of particles. Mixtures are made up of two or more pure substances or compounds. These substances are chemically different and cannot undergo a chemical reaction. The properties of the mixtures are due to the substances or compounds which constitute the mixture. Components of a mixture can be separated only by physical methods. For example, even if we increase the amount of sand or sugar, the components still be distributed among each other as they were present before, which means a mixture may contain different substances in variable ratios. To see this, let us perform an activity. Take water in a beaker and add salt to it to prepare a salt solution. Similarly, take water in another beaker and add soil to it and prepare a solution. Now we observe that in salt solution, we do not see any salt particles at the bottom of the beaker, whereas in the soil solution, particles of soil settle at the bottom of beaker. So this shows that on the basis of size of particles, mixtures can be divided into two categories, homogeneous mixtures and heterogeneous mixtures. Those mixtures which have uniform composition are called homogeneous mixtures or solutions. This solution is a homogeneous mixture of two or more substances. The substance present in larger quantity is called solvent and the substance present in smaller quantity is called solute. For example, salt solution. Here, salt is solute and water is solvent. On the basis of nature of solute and solvent, homogeneous mixtures may be categorized as liquid in liquid solution, solid in liquid solution and gas in liquid solution. In solution of vinegar in water, vinegar is solute and water is solvent. Since both the substances are liquid, so this is an example of liquid in liquid solution. In a solution of salt in water, salt is solute and water is solvent. Salt is solid, so this is an example of solid in liquid. Similarly, soda water like Coke which you drink is an example of gas in liquid solution. In such solutions, carbon dioxide is solute and water is solvent. Air is a mixture of gases and is an example of gas in gas solution. Children, now let us know about properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer in diameter. That means they are very tiny. The particles of a solution cannot be seen with naked eye. Because of their small size, particles of a solution do not scatter a beam of light passing through it. The path of light is not visible in a solution. The solute cannot be separated from solvent by the method of filtration. Students, now we shall discuss about saturated and unsaturated solution. Saturated solution. When no more solute can be added to a solution at a particular temperature, it is called a saturated solution. Unsaturated solution. If more solute can be added to a solution, it is called an unsaturated solution. Students, now we will know about solubility. The amount of solute present in a saturated solution at a particular temperature is known as its solubility. Concentration of a solution. Equation for concentration of a solution is concentration of a solution is equal to volume of solute divided by volume of solution multiplied by 100. There are various methods to calculate concentration of a solution, but we will discuss only two methods here. Mass by mass percentage. The formula is mass of solute divided by mass of solution into 100. Second method is mass by volume percentage, which is equal to mass of solute divided by volume of solution into 100. Let us solve an example. Example, in a solution, 40 gram of common salt is dissolved in 320 gram of water. Calculate the concentration of the solution. Now, mass of solute is equal to 40 grams. Mass of solvent is equal to 320 grams. Now we know that mass of solution will be equal to mass of solute plus mass of solvent. So, when we substitute the values, we get 40 grams plus 320 grams is equal to 360 grams. Mass percentage of a solution or concentration of a solution is equal to mass of solute by mass of solution into 100. Substituting the values, we get 40 divided by 360 multiplied by 100. On solving, we get 11.1%. So, the mass percentage of this solution or the concentration of this solution is 11.1%. Students, now we shall know about heterogeneous mixtures. Suspension and colloids are two types of heterogeneous mixtures. Suspension, a mixture in which solid is suspended in a liquid, it is called a suspension. Suspension is a heterogeneous mixture in which solute particles do not dissolve in a solvent, but remain suspended in the medium. These suspended particles can be seen with naked eyes. For example, mud in water. Now we will discuss about colloids. In colloids, the particles are uniformly distributed. The particle size is smaller than suspension, hence the mixture appears homogeneous. For example, milk. Due to smaller size of particles in colloid, these particles cannot be seen with naked eye, but these particles can be seen with the help of an electron microscope or ultra microscope. Students, now we will see the effect of light on homogeneous and heterogeneous mixtures. Let us find out how light affects a colloid. When we add egg white in a beaker and add some water to it, so the egg white and water mix together to form a colloid. When we pass light through the beaker with the help of a torch, the colloid particles scatter the beam of light and path of light becomes visible. This effect of scattering of light was discovered by John Tyndall. Hence, the effect is named after him and called Tyndall effect. Light cannot pass through suspension. Let us know about the properties of a suspension. Suspension is a heterogeneous mixture. The particles can be seen with naked eye. The particles scatter the beam of light passing through the suspension and the path of the light becomes visible. When left undisturbed, the particles settle under the effect of gravity, hence suspension is an unstable mixture. The particles can be separated by the method of filtration. Now let's discuss about the properties of a colloid. It is a heterogeneous mixture. The particle size is so small that they cannot be seen with naked eye. The particle size is big enough to scatter a beam of light and the path of light becomes visible. When left undisturbed, the particles do not settle at the bottom, that is, they are stable. The particles cannot be separated by filtration but are separated by the technique of centrifugation. Colloid is prepared by dispersed phase and dispersing medium. The solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which dispersed phase is suspended is called the dispersing medium. Colloids are classified according to the state, solid, liquid or gas, of the dispersing medium and dispersed phase. Students, now we will know about the methods of separating the components of a mixture. The different methods are evaporation, centrifugation, bi-separating funnel, sublimation, chromatography, distillation technique and by crystallization. Students, first we will learn about the technique of evaporation. We will try to understand evaporation with the help of an activity, so let's perform our activity. Fill half a beaker with water, put a watch glass on the mouth of the beaker, put a few drops of ink on the watch glass. Now start heating the beaker. We do not want to heat the ink directly. You will see that evaporation is taking place from the watch glass. Continue heating as the evaporation goes on and stop heating when you do not see any further change on the watch glass. Observe carefully and record your observations. Students, What do you think has got evaporated from the watch glass? Is there any residue on the watch glass? What is your interpretation? Is ink a pure or single substance, or is it a mixture? We find that ink is a mixture of dye in water. This we can separate the volatile component solvent from its non-volatile solute by the method of evaporation. Students, now we will learn about centrifugation. Small solid particles in a liquid cannot be separated by filtration. Such mixtures are separated by centrifugation. The principle is that denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly. For example, separating butter from curd with the help of a churner or mixture. Students, now we will use a separating funnel to separate the components of a mixture. Let us try to separate kerosene from water using a separating funnel. Pour the mixture of kerosene oil and water in a separating funnel. Let it stand undisturbed for some time so that separate layers of oil and water are formed. Open the stopcock of the separating funnel and pour out the lower layer of water carefully. Close the stopcock of the separating funnel as the oil reaches the stopcock, so we can separate the immiscible liquids like water and oil separate out in layers. The process of sublimation. Students, you know that after the winter season, we keep our woolens, sweaters and blankets properly and add naphthalene balls to these woolen clothes, which are available in the form of small balls of white color. You must have kept these balls along with woolens last year also. And when you will take out these woolens in the next winter season, you will observe that the naphthalene balls are reduced in size. So where did this solid go? You will also observe that woolens have that peculiar smell of naphthalene. This means that solid vaporized and absorbed by the woolen clothes. This solid substance changes into vapor state directly without changing into liquid state. This method is called sublimation. This method is used to separate a sublimable volatile component from a non-sublimable component. For example, a mixture of salt and ammonium chloride can be separated by this method. Take the mixture of salt and ammonium chloride in a china dish. Keep an inverted funnel on the china dish and close the funnel with the help of a cotton plug. Heat the mixture on a burner and you will observe that ammonium chloride is changing into vapors. Ammonium chloride undergoes sublimation and vapors of ammonium chloride, when come in contact with the funnel, again change into solid and deposit on the funnel. So we can see that ammonium chloride deposits on the funnel and common salt is left behind in the china dish. Students, now we will learn about chromatography. Take a thin strip of filter paper, draw a line on it using a pencil approximately 3 cm above the lower edge. Put a small drop of ink soluble in water at the center of the line and let it dry. lower the filter paper into a jar or glass or beaker or test tube containing water so that the drop of ink on the paper is just above the water level and leave it undisturbed. Watch carefully as the water rises up on the filter paper and record your observations. As the water rises on the filter paper, it takes along with it the dye particles. Usually, a dye is a mixture of two or more colors. The colored component that is more soluble in water rises faster, and in this way the colors get separated. Students, now we will learn about distillation method. This is our next method in which we will learn about separating the components of a mixture. Students, let us try to separate acetone and water from their mixture. Take the mixture in a distillation flask, fit it with a thermometer. Heat the mixture slowly, keeping a close watch at the thermometer. The acetone vaporizes, condenses in a condenser and can be collected from the condenser outlet. Water is left behind in the distillation flask. Students, this method is called distillation. It is used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. To separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 Kelvin, fractional distillation is used. Students, now we will see another method of separating components of a mixture, and it is crystallization. In this method, we will study about obtaining crystals of copper sulfate from a solution of copper sulfate. For this method, we need a saturated solution of copper sulfate, a thread, solid copper sulfate. Students, first we will prepare a supersaturated solution of copper sulfate. First of all, we will ignite a burner. Then we will keep the beaker containing saturated solution of copper sulfate on it and add copper sulfate to this solution till it stops dissolving in the solution. This also indicates that as the temperature increases, solubility of substances also increase. Now tie a thread to a pencil and hang it in an empty beaker. This thread will help in accumulating crystals of copper sulfate. Now add the supersaturated solution of copper sulfate to this empty beaker and leave the beaker undisturbed for a few days. Students, after a few days, we will observe crystals of copper sulfate on the thread, which appear very beautiful. Students, now we shall learn about physical and chemical changes. The properties that can be observed and specified like color, hardness, rigidity, fluidity, density, melting point, boiling point, etc. are the physical properties. The interconversion of states is a physical change because these changes occur without a change in composition and no change in chemical nature of the substance. For example, ice changes to water no new substance is formed in this. Chemical properties of substances are different due to different chemical composition. A change in which chemical composition of a substance changes and a new substance is formed is called a chemical change. For example, iron reacts with oxygen in the presence of water to form iron oxide, that is rust, which is a new substance. A chemical change is also called a chemical reaction. Students, now let us study about pure substances. Pure substances are of two types, elements and compounds. Now let us know about elements and compounds. An element is a basic form of matter that cannot be broken down into simpler substances by chemical reactions. Elements can be normally divided into metals, non-metals and metalloids. Students, now we shall see the properties of metals. They have a luster, they have a silvery grey or golden yellow color, they conduct heat and electricity, they are ductile, that is, can be drawn into thin wires. They are malleable, that is, they can be hammered into thin sheets. They are sonorous. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Now we shall see the properties of non-metals. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous or malleable. Examples of non-metals are hydrogen, oxygen, iodine, carbon, bromine, chlorine, etc. Compounds. A compound is a substance composed of two or more elements chemically combined with one another in a fixed proportion. Examples of compounds are water, sugar, common salt, carbon dioxide, etc. Now let us recapitulate what we have learnt today. We studied that in a mixture, the components can be mixed in any proportion. A solution is a homogeneous mixture of two or more substances. Materials that are insoluble in a solvent and have particles that are visible to the naked eyes form a suspension. Soda water, coke, etc. are examples of gas in liquid solutions. Colloids are heterogeneous mixtures in which dispersed phase is distributed in the dispersion medium. To separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 Kelvin, fractional distillation process is used. Elements can be normally divided into metals, non-metals and metalloids. Properties of a compound are different from its constituent elements, whereas a mixture shows the properties of its constituting elements or compounds. Now I'll ask a few questions and hope that you might be knowing the answers. Okay, my first question is, which separation technique is used to separate oil from water? So the answer is by using a separating funnel. Second question, what type of mixtures are separated by the technique of crystallization? The answer is pure solid from a solution. Next question, classify the following as physical and chemical changes. First, cutting of trees. What kind of change is it? Yes, very good. It is a physical change. Now, second is rusting of iron. So, students, which type of change is this? Absolutely correct. It is a chemical change. Next question. Explain the following with the help of examples. Saturated solution. Saturated solution, a solution in which no more solute can be added at a particular temperature, is called a saturated solution. Now, next definition is sublimation. When a solid directly changes into its vapor or gaseous state, or a gas changes directly into its solid state, the process is called sublimation. For example, ammonium chloride, camphor and anthracene. Next definition is centrifugation. The method in which denser particles are forced to the bottom and the lighter particles stay at the top when spun rapidly is called centrifugation. Example, separation of cream from milk. Washing machines to squeeze out water from wet clothes. Blood and urine tests in diagnostic laboratories. Next question is, state any two differences between mixture and compound. And the answer is, elements or compounds just mix together to form a mixture and no new compound is formed. A mixture shows the properties of the constituent substances. Compound, elements react to form new compounds. The new substance has totally different properties. With this, we complete our chapter, and I hope that you must have listened it carefully and understood it well. So students, stay motivated towards your studies and stay safe. Thank you.